So just let me know when you want to start.
So, góðan daginn öll. Hello everyone, and welcome to today's seminar on blockchains, or in this case, smart contracts. Our speaker today is Mohammad Hamdaqa. Before we start, can I ask Christian, do you have any announcements or anything that you want to make before we start?
No, not this time.
Okay, then the floor is yours.
Okay. So hello everyone. Thank you for having me today here to talk about a topic that I'm passionate about, which is smart contracts. So during this presentation, I will have like a few slides where you will be interacting and sending maybe responding to some of the questions. So I will ask you to log into menti.com or just scan this QR code on the screen and put this digital code so that you will be online in the room. Okay, so as mentioned, like I work at Reykjavík University. I'm an assistant professor there, and there I am co-directing the Financial Technology Center and running the Software and Emerging Technologies lab, which I call it SITE in Icelandic, because I use models and the beauty of models in addition to other software engineering techniques to help bridging the gap between software engineers and emerging technology platforms such as cloud computing and the Internet of Things, and of course today's topic, which is blockchain. When we're talking about the blockchain in the context of software, we're normally talking about smart contracts. So today's talk will start with an introduction into smart contracts, so that we can all get into speed of what is a smart contract, how smart contracts work. Then I will highlight some of the challenges toward the adoption of the smart contracts, and at the end I will highlight some of the research activities that's currently conducted in my research lab. So to start, I think I will start by asking you, do you use smart contract, or did you use smart contract before? So log into Menti and try to answer. So, okay, so we have 6 people here more. Okay, I'll wait another minute or so, or few seconds before moving to the next slide. Okay, so as I can see, like some of you used smart contracts before. Most of you never used smart contracts before. So today's talk hopefully will introduce you to this concept. So according to Nick Szabo, who coined the term smart contract, the granddaddy of smart contracts is the vending machine. So if you used a vending machine before to buy a can of soda, then like you used a kind of smart contract. So smart contracts, they're also using simple state machines. They're programs that simple if then that, similar to the vending machine, where you deposit deposit some money in the vending machine and get the can of soda in return. In smart contracts also, it codify some kind of conditions and agreements. Based on that, normally in typical cases, there would be an exchange of kind of assets or coins or other kind of what we call them digitized assets. So what's the difference between a normal program and a smart contract? in normal cases, if you develop a program, which can be also kind of conditional program that codify some kind of agreement, you will generate or compile the code and generate the bytecode or the opcode, like the bytecode, and then deploy this into your PC or server and run this code. So how this different from smart contract? In smart contract, in fact, we do very similar operation, very similar steps. You write the code, then you generate the bytecode, but instead of deploying it in your PC, then you will be deploying it in blockchain, such as the Ethereum blockchain. And since it's deployed on the blockchain, it will inherit many of the properties that blockchain provide, such as immutability. So the code will not be easy to change. Well, like theoretically, we can say it will not be able to change, but yeah, I can tell you that it will not be easy to change. And since it's immutable, it provides us with other properties such as transparency that helps to build this concept of trust. So first of all, we can eliminate intermediaries because now the code is the contract. It provides a way to verify these kind of code that we have, verify that it's correct, because no one can now tamper with this code, no one can tamper with this application. So, and anyone can access to this application in the case of public blockchain deployments. And this hopefully will provide us with trust. And if we provide the trust, then we can solve many problems that we face in our life when we do exchange of any kind of transactions. So to give you a better idea of the smart contracts, let me start by a simple example. So this is my family, and for people that they know me, my family typically like living in Canada, and I live here in Iceland. And like you see my two daughters and my son, Adam. Adam, he's the mischievous boy, so he's the one, most likely the one with the troublesome in the family. And it's very hard to make him commit on something, so to take commitment from him. So as I'm living far away, normally I ask him, well, if you do, to motivate him to work, if you do good at school, then I will give you some kind of prize or maybe $100 gift so that you can do whatever you want. So to understand the problem in a better way, let's see this TikTok video.
Hey, Mommy.
What?
Would you ever punish me for something I didn't do?
Of course not.
Good, because I didn't do my homework.
Smart ass.
So as you can see, like it's very hard to give for Adam to give commitment, because he will always find his way around. So in order to work around this problem, and since I know smart contracts, we decided that we write a smart contract between me and Adam, so that the rules are very simple, that I will deposit this $100 into this smart contract, and Adam will not be able to take this money unless the teacher updated the grade, and the grade is A. So if the grade is A, he will take the money. So this is the simplest maybe form of a smart contract that you have. It's very simple, if then that program. If we want to see the actual code behind this smart contract, it will look like this. So you will have, for example, this is the program written on Solidity, which is the programming language that is used normally to write smart contracts on Ethereum or for Ethereum. So as we can see here, like the first thing that you need to define if you want to define a smart contract normally is the state, the asset that you have. So in this case, the state variable that we store is the grade, the class grade, which will be updated, the contract balance, the amount of deposited value that we have, and we have 3 addresses here: the address of me, Adam, and the teacher. Those are the addresses of the wallets, or the addresses where the exchange, like the actual transaction initiated from. And we have here a Boolean variable, money withdrawn, is just a Boolean variable to like state that if the money has been withdrawn or not. In addition to this, normally in smart contracts, because it's kind of programming or contract by design programming languages, you need to have these kind of preconditions and modifiers. So the modifiers are constraints that state when I show you the functions now, which role, which person, in this case, like me, Adam, or the teacher, has access to the different functions. So in this case, for example, we have 2 functions here. Those are the main functions that we have. We have withdraw functions and set grade function. So only Adam can access this or execute this withdraw function, and only the teacher can run this or execute this set grade function. You can also have events, as you can see here. Events normally just for logs. You may want to use it. This is optional. Anyway, all transactions will be logged on the blockchain. So even if you don't use the events, you still can log the transactions. So let me explain this function, because we will refer to it again in this talk. So this withdraw function, as we can see, we have preconditions. So only Adam can execute it. It requires that the contract balance is greater than 0. It requires that the grade, class grade, equal A, and here it's hashed because we don't want to show the values. We can just, so you don't want to send them in plain text. And you can just store the previous balance of Adam. And we have here the most important line of code, which is if Adam called this function to execute this smart contract, then he will call it with his address, right? And so the transaction will be signed with his key and originating from his address. And here this function, what does, it sends or do transfer of the contract balance to this address, which is the sender address, which is Adam. So only Adam can execute this function, and when he executed this function, he will receive the money back. It's like inversion of control. And then you set the value to 0. And set the grade is just set the grade, and only the teacher can set or change the grade. So this is very, very simple smart contract. So once you write this smart contract, you need to deploy this smart contract. So in order to deploy this smart contract, you generate the byte code here, as you see, and then you send this byte code, you store it in the blockchain. To store this in the blockchain, you normally send this as a transaction. So from the owner address, which is me, to, well, will be like normally sent to a node in the Ethereum blockchain, and this will delegate it to store it. And then if you know how blockchain works, it will be like consensus on this transaction, and then it will be stored, and it will be given a specific address for the contract. Now, anyone that want to use this contract can now execute transactions against this contract. Of course, if they have access, like they're the right people, and they can execute the function. So in order to execute any transaction, you need the from, which is Adam, for example, and to, which is the contract address. Then we have value. If there is value to be like as part of the transaction itself, for example, the first transaction may have value to deposit money. And then you have the data input here, which is start with the function selector, which is which function you want to execute. So this will be like match one of the opcodes here that we want to like, or the function that we want to execute. From this like point, we will start to executing, and the argument that we have. And we set two parameters here that they're important and important to understand now, is something called gas limit and gas price. So what's gas limit and gas price? Anyone knows what's gas limit and gas price? Okay, I will explain them for now. So the gas limit and gas price, there are two parameters that used for ensuring that all transactions will be executed, the network will not stall. So the gas limit is set normally by the developer, and it will tell you, or like the one that will send the transaction, and I say, okay, this is my limit of how much unit of gas measurement I want to spend. So the higher that you set this value, the more guarantee that all the transaction, all the operations in your function will be executed, or in your transaction will be executed. Because to give you also like overview of how this works, so each of the functions that you have, each of the opcode, opcodes for your smart contract, executing it will cost will cost you some gas, and this is different based on what operation you're doing. So if I set this for a large number, then I have enough gas to execute all my transaction, and when the miner use this, they can execute the code, and they will be compensated, and the rest will be returned to you. The gas price, on the other hand, is a value that you set in order to say, okay, I'm willing to pay this value per unit of gas. And the higher the price you put, then miners will be happy to take your transaction first, because you're paying more money for them per executing the transaction. So both those parameters, so the gas price can set the priority for your transaction. The gas limit can show how much money you're willing to pay in order to execute the transaction. So if you set this very high, of course, is this good or bad? Well, if you set this is really like the gas limit really high, then people if there is a bug in the contract, this may consume all the gas units and you will lose money. So you want to set it in with fair amount so that you make sure that your transaction will be executed. At the same time, not low that the transaction will be failed. So you will lose the money without having the goal done. So this is an overview of smart contracts from development to deployment and executing the transactions. If you have a question, you can ask. If you don't, then well, I'm glad that you already know how to write your first smart contract, deploy it and manage it. All the rest will be details if you want to learn about smart contracts. So, well, this is great. So the code now is stored in a way that is tamper-proof. No one can change it. And since the code is tamper-proof, no one can change it, I can now use the code as my law, use the code as my contract with anyone else, and I put the conditions in the code itself. So what kind of application you envision that can use this kind of smart contract applications? So you can type your answers and we will be able to see them. So maybe the most well-known case, for example, in case of Ethereum, we have working or not?
Sorry, what was the question?
So yeah, what kind of applications we have for smart contracts? What kind of applications do you envision for using smart contracts? These code, these contracts, or these programs that are immutable, like cryptocurrency, maybe one of them, right? So cryptocurrency is based on smart contracts. Other kind of applications could be, I'm not sure if this is working or not, because yeah, okay, loan screw tracking, simple crypto financial transactions, okay, supply chain management maybe, right? Because you keep track of who did what, and anything that requires data to be immutable also, or requires some kind of rules in order to govern relationship. So any kind of contract. So whether we're talking about loans, we're talking about insurance, we're talking about managing the like house or voting, any kind of voting also will work in this regard. But the main idea here, I think, and which is where this is going, is that at the end, what these kind of programs provide us, it provide us with a way to remove intermediaries, but also provide us to a way to provide trust. And trust is one of the paramount key elements in order to well, enable digitization. So if you heard this concept of digital transformation, this is all based on our trust in the digital environment. So today, for example, we hear a lot about this advancement in AI, machine learning. Also, this raised very much concerns on other topics, such as those that we hear them under the name of deepfake. So everything can be, we can create replicas from anything, this including your identity, personal identity. So at the end, we need a way to provide some kind of traceability to the origin, whether we're talking about supply chain or origin as a person or as an asset. So in the next generation of Web3, the Web3 will be mainly depends on our ability to create these digital identities and to relate those assets, those identities to its origin. You can think of word of virtual reality and virtual words, and you have many identities, but we need at the end to trace these identities to one. We need to be, in order to have trust, we need to be able to say that, okay, if I have some kind of asset, I have an actual link to this asset in digital form, and this digital form will not be able to change. And this hopefully will enable the next generation of Web3 and will enable us to build global banks and provide us with the trust required in order to reach what we call the liquid circular economy. So trust can help us to have digital assets that we can trust. And digital assets, if we were able to really realize this concept of digital assets, we will be able to have liquid economy. So now I can do exchanges through simple transactions. In order to, of course, for this liquid economy to work and to keep moving, we need some kind of game theory approach. This is what blockchain, for example, did by having this concept of miners and implementing greed as part of the chain itself, because this kind of approach create a way to keep the market always moving, and this hopefully will help us to achieve the liquid economy. So as we can see now, smart contracts seems to be solving really important problem for us. So it will provide us with the trust required, and if this will take us to cloud 9 now. So we're happy. We should be happy. However, there is very small problem with the smart contracts, is that the smart contracts, unfortunately, they're not smart and they're not contracts. So they're not contracts because they're code. We always call them self-enforced, but what self-enforced means? In order for smart contracts to be self-enforced, so if we say that if then that, so if the conditions met, so if I tell you that if I deliver a really good presentation today, you will compensate me $100 for my presentation. How you can make sure that I delivered good presentation? How the computer, which is the contract itself, will know that I delivered a good presentation? It's impossible that the computer will know that without kind of oracles. And these oracles require trusted services. So a service that I trust to provide this kind of oracle so that the transaction, the condition will be met and executed. This is very hard problem. And this is on the core of digitization and digital assets, and how we can convert digital assets and oracles into digital form that can be trusted. Another problem is that, well, yes, we achieved immutability through these smart contracts, and this is wonderful. But this immutability means that also that if I find a fault or problem in my contract, this fault or bug will become immutable. So, and we know that from Dijkstra that it's impossible to write a code that's bug-free. There is many ways that we will get bugs and problems and faults in our program. So how to deal with these immutable bugs? Moreover, who use these smart contracts? If these are replacing law, then people that they use these smart contracts, normally they're lawyers. They're people that maybe with not enough technical knowledge to read these kind of complex programs that even skilled programmers sometimes find difficulties understanding them. So smart contracts, they're not smart. In fact, you need to be smart in order to understand and write smart contracts. So let's focus on one problem here, which is the problem of immutable bugs. So let's say that a bug happened and you already deployed your smart contract, and now the contract is immutable, your code is immutable. So what options you may have in order to address this? So how I can solve the problem? I have now contract, I have code, I deployed it, it's become immutable, then I discovered that there is a bug. So anyone knows how this is handled today? So the question again, that I deployed the application, okay, swap out part of the contract, okay, which is like so are you talking about redirecting here to other part or just kill it? Okay, rewind the chain, that's right. So this is one way to do it. So I will walk you through this. I think it's not a fair question to ask for people that they never wrote smart contract before. Okay, so the first approach that is normally done is, well, you have, let's say that you find an exploit and you have black hat hackers that they try to use this exploit. So what you can do is that you can hire white hat hackers that they can, well, use the same exploit, and the first one who win, like the faster hackers are the one that will be able to cash up the money and like return the assets first. And this approach has been used recently a lot in some of the contracts where exploits has been discovered in order to be able to protect the investors. We will see example today on this. Or you can also implement some bug bounty programs where you can give investments for gray hat hackers so that they will try to find exploits in order to find them as soon as possible, so that you can find some remedies. And the other approach, which has been mentioned in one of the answers, is rewriting history, which is what we call it in blockchain as hard fork. So imagine that this did not happen. Now the problem with this is that let's say that we already did have now a program that is like they're deployed, and we want to track back rewind the changes. Then what we can do is that we can imagine that this event did not happen, and everyone need to agree to go to a previous step, to a previous block, and start from there again, which is very difficult and require consensus from the whole community. This happened so far several times, but with difficulty. And the third case, which is what currently implemented in smart contracts, is this self-destruct behavior of the contract itself. So this is Inspector Gadget, if you know him, and he has this ability, or normally when he receives the messages, these messages have specific amount of time until it will be destructed. So currently, smart contracts have these kill function behavior that the owner can kill the function. Of course, you can put restrictions on killing the smart contract, and when you kill the smart contract, what you do is typically you disable the contract, so it will not be useful anymore. Of course, you can delete it, but you can make it deemed unusable. So these are some ways to deal with the problem. There is also some other ways that, in fact, I call them they normally introduce more faults and more problems, such as having like a chain where you link a smart contract to another smart contract, and you can call the first one from the second one, and yeah, this introduces other kind of problem. You can ask me about this maybe later. So what can go wrong, and can we really trust a smart contract? It seems that we can't trust a smart contract because there's many things that can go wrong, that can introduce faults and errors in your code itself. So the code can be buggy in other people's codes. So if you depend on libraries, other libraries can have problems. In the transaction itself, there could be problems. So we saw some examples where the transaction can be, for example, padded in a way that change the value in the transactions. The IDE can go wrong. So you use some IDEs to compile the code. So what if the IDE has some malicious code in it itself when it compiles the code? So the code chain, the one that generates the actual code, can cause problems. The platform, such as Ethereum, can have also some exploits and problems, and external applications that use your application can have problems, and the protocol, which is the order in which the operations are executed, can go wrong. So let me give you some examples, and I will go with you through some of these examples very fast. So as we know, like these bugs cannot be avoided, and we saw through the history since the first smart contract was created, many of these bugs that proved that these contracts are not safe and resulted in, well, catastrophes in many cases, with like millions and millions of dollars in losses. And these just are examples. So let me give you example of each type or each category that I mentioned before. And let's start with the most famous maybe exploit and one of the first, which is the DAO contract. If you heard about the DAO contract, which is the decentralized autonomous organization, like DAO refers to, this exploit happened in a contract that is very similar and simple and very similar to the first contract that I showed you the code for before, the Adam and me and the teacher one. So this specific DAO organization, the one that we're talking about where the exploit happened, the contract itself, the goal of it was to implement this crowdfunding investment feature or ability where several investors can come together, they deposit money, they deposit some ethers, and then they vote in some kind of projects, and based on that, the money can go to that project. Now, one of the features that has been implemented in this contract is that, well, according to the government, we, like participants, should be able to like split or take the money that they have like before the voting happening. And the way that this is done normally, like they like implement the split behavior where you create another like copy of the contract with the amount of like that he deposited. You can withdraw it, and it will be available for like it's frozen for a certain amount of time. So okay, let me show you the code first of this contract, because hopefully you will be able to read it and understand it. So this is the code. As you can see, they have here the withdraw function. So any of those investors can split or can withdraw the money. So they can have this DAO withdraw, which will call the withdraw function, and this will call message sender.call.value the amount. So it will return the value back to the contract owner, and they will get the money. So I withdraw the 100 ether and I try to withdraw again, and I get 0 because the value is set to 0. So anyone see any problem with this contract? So I will tell you the problem. So one of the problems, in fact, there is many problems in this contract that can be fixed. So one of the problems, as you can see here, we have balance dot, like they set the balance to 0 after this callback is executed. So what happens when this message or when this line of code executed is that you return the money back to this user, and this will be handled automatically by what we call fallback function. So this fallback function will be always called when there is no signature that matches the call that you have. So in this case, I will call the fallback function, which is payable here, and it will call again the withdraw function. So what will happen now? So I called this, it returned the money. Then after I returned the money, this is not set to 0 yet. So I returned the money, it went to call back, and this will call the withdraw again. So I call the withdraw again, this will send the money back. I did not set the value to 0, and I will go into recursive calls. This exploit was used by the hackers to deplete $50 million of the DAO contract. The DAO contract value were 150, and they were able to get access to $50 million using this kind of hack. So simple solution to this, okay, instead of doing this balance equals 0, just reverse the order of these. So set the balance equals 0, then send the money back. If you do this, then if I call the DAO again, it's already set to 0. So this is one kind of solution, but there is many other problems in this contract in general. One of them is the use of this call. So this use of call, in fact, there is different ways to send the money back. There is call, there is send, and there is transfer. If you use call have a specific feature that it does not have gas limit, as you can see on the other two transactions. So when I call, I can keep, like, I can set the gas, like the transaction gas for very high limit, and this will keep like executing the transaction for infinity, as long as I have like calls and I have operations to execute. So if you use any of these safe functions, at least even if this has happened, then after the money, after like the gas is expired, then this will be failing. So you will not be able also to withdraw that amount of money. So I mean, there is different problems here that you can look at. In fact, there is also some other problems. One of them is related to the Ethereum first like implementation, where also the like something like underflow problems, which is typical programming checks that normally even any programming language normally checking for underflow were not checked at the first implementation. So in the underflow, for example, if you have like 256 field like unsigned integer, and let's say that you deposit one ether and then withdraw 2, then you go to -1, which is because it's unsigned, it will set it to the maximum amount. So this also was used in some other exploits. Now, using locks and unlocks, this is create other problems in distributed system behavior, because imagine that you lock the contract. Let's say that I locked this part and I did not come back to unlock it, because this is distributed system, right? So I can send the transaction that lock and then forget about it. And this will lock the whole contract forever until you unlock it. So, I mean, these kind of problems, even like the simplest one, when you work on distributed decentralized systems, this can be become a problematic issue. So this is part of the Ethereum specific problems, right? What about or Solidity specific problems, so the programming language? There's also exploits and problems happening from the platforms, so platform specific problems. And one of them was the Shanghai DOS attack. This is a series of attacks. I will explain one of them. Those attacks started, in fact, before one of the conferences that Ethereum were planning to present about Ethereum. And well, after they solved the first problem, this is in fact was the second problem that they had. So the idea in this attack was as follows. So the attackers found the cheapest opcode. So as we mentioned before, like each opcode, such as this opcode, when it's executed, it requires some, it has some gas price. So they found one of the cheapest one, but have the highest cost in terms of performance. And they were calling this external code size, which is just return the size of the code that you have. They were calling it more than 50,000 times per block, which slowed down the network, I think, between 2 to 3 times or 2 to 3 folds, the whole Ethereum network, causing it to slow down and, of course, result in many transactions failing. There was many solutions to this problem. In fact, in the recent, subsequent implementation of Ethereum. So, and one of them was to increase the cost of these opcodes for the gas. There is also things related to, as I mentioned before, other people code. And one of the problems that related to this specific type of problem is the code dependency problem. In the code dependency problem, which happened in the Parity wallet, the Parity wallet is multi-signature wallet where multiple people need to sign before the money will be transferred. Now, the problem in this specific case is that in some of the functions, such as the init function in this case, were set to be public. So this is the constructor of okay, let me first explain how the dependency problem is. So in these kind of applications, such as the parity wallet, what you do is you implement a specific kind of architecture, which is child-parent architecture, in a way that since you create multiple child wallets, you don't want to deploy those or to deploy the whole code with several times. So what you can do, you can refactor and have a parent wallet implementation that will be deployed once. And every time you create a new wallet, you just deploy the part that is the difference part. But all of them will depend on executing the parent wallet code or contract. So the problem here in the parity wallet is that what happened if a problem happened in the parent wallet? It will affect all other wallets. And the problem in this case, that the parent wallet had a function to initiate that wallet, which give the developer access to be the owner of the wallet, the main contract, the parent contract. And in this case, the developer get access, one of the developers get access to the parent contract. And they were trying just to implement things and change things, and they accidentally killed that contract. So once you killed that contract, because all other contracts depending on it, all contracts were frozen, and you were not able to deal with the money or to work with the money like in the other contracts. This resulted in freezing what they like estimated to $300 million. And this is the message that the developer wrote after they did this. So it was DevOps 199. He wrote in, or she wrote on the GitHub, like, I accidentally killed it. Will I be sued for this? And yeah, this in fact has been solved, this problem, by hard fork in 2019, February 2019. There's the ID and coded chain building problem. Well, today, most of the frameworks that we're talking about, the code, like we encourage open source, right? And this means that you can have it in GitHub and you can build the tool in an automated way, but this is also have the potential for, implementing some kind of backdoors in the IDE itself, so which requires like checking the IDE itself. And there is protocol problems. You know, like if you, for example, play the like rock, paper, scissors, the last player will always be the winner if he or she see the other two players moves. This is, of course, happening in smart contracts in terms of miners too. Like miners can, for example, see what transaction they have 90 seconds to arrange these transactions, and they may like do this in favor for them to get access to, for example, if you're doing exchange market or stock market and you want to buy, you can know which one buying, which one selling, and you can arrange a transaction in your favor. A solution for this can be with hashing and there's other also approaches. So this is sample of some of the exploits that's available. So how to deal with these exploits? Well, there's many ways to deal with this. Some of them, so we can first classify those into two parts. The similar, like the classical problems and the domain-specific problems. So the classical problems we know, like from modeling and formal specification, static analysis and symbolic execution, dynamic analysis, empirical approach, all of them were used before for the classical problems. This approach also can be extended for the new domain-specific problems related to Ethereum, like the platform, the language, and we see more and more work on this. These are, for example, some of the static analysis tools that's available today that you can run them on your smart contract. This is also open like the opportunity for many auditing company. There is many like this, there is trend today in the market toward building these audit companies for code and for contracts, which is needed because like consultation were done for a long time in other engineering discipline, less in coding. And we see more now move toward consultation in this domain to make sure that the code is correct and does not have issues. So as part of the work towards like more safe, smart contracts, more trustworthy smart contracts, I run currently several projects in this domain with the theme toward like I contracts, which is intelligent smart contracts that I define them as self-executing protocols that automatically generated from human readable domain contracts and hold their safety and security guarantees with them. Now this project have different parts. There's the self-executing part, how to really achieve this kind of self-execution through like trying to capture the intent, provide trustworthy oracles. This is like an open problem, in fact, that we have some directions toward there, but I mean, there is no concrete solution till today to this problem. I work also on the like bridging the gap between the non-technical users and the technical ones, or how to be able to enable, for example, lawyers and other stakeholders in the process of creating contracts in order to be able to read, write, and generate code for smart contracts, and also how to be able to check and prove that the smart contracts are correct before deploying them. And yeah, there's several projects, as I mentioned here. This is high-level architecture of the framework that we're working on. Yeah, and one of the topics that I'm interested in particularly is creating this smart contract layer domain-specific language. Recently, we developed this iContract language that enables you in an easy way to build the smart contracts in a simple way. For example, this is the example that we had before for the me, Adam, and the teacher. You can just like drag and drop the roles that you have. You can have functions, as you can see, and you can have the asset, which is the grade that we have, which is the state variable that we have. And from this, you can easily generate the code based on the target platform, whether it's, for example, we currently support Ethereum and Hyperledger and what else? There's, yeah, Azure blockchain. And this has been recently published in the SAM 2020 conference, and we're extending it now today to support, in fact, being able to use conversational agents to generate these models in an automated way without the need for even writing and drag and drop these components. So you say, okay, I want to contract, the chatbot will ask you what kind of contract, and it will like take you through the steps of building these contracts, and we generate the code in an automated way from these kind of contracts. We have other projects where we try to automatically detecting and patching the smart contract vulnerabilities. One of my PhD students working on this, and she is following like empirical and static analysis approach. So to be able to classify vulnerabilities, then be able to detect these vulnerabilities in code, and automatically using like neural machine translation to be able to generate patches for these smart contracts on the fly. And we have also another project that one of my master students working on, in which we collected over than million smart contracts. We created this graph of contracts with the relationships and owners, and we're currently analyzing this to provide traceability in order to be able to, if a problem happened in one contract, to patch this contract in an automated way. So all this work, in fact, is in one aspect, which is correctness by design and construction by design for smart contracts. There's many also gaps in this field till we reach really trustworthy smart contracts. And in addition to all these technical problems, there is the legislation problems that we may have. So we're talking about contracts replacing law, but well, are we ready for that? Well, in Iceland today, if you want to be able to use a document as legal document, as a contract, then this document needs to be printed as four hard copies in A4 size, written in typewriter or computer, and put together in paperclip or stable. So if this is the law today, so I mean, we still, I think, immature in this field till we reach the goal that we want, which is achieving the trust that we need in order to build this liquid economy platform, and that will enable the Web3 decentralized web. But I mean, as we following the money, there is opportunities, and I think one day we will reach this trust. I have faith that we will reach this trust at some point that will help us to trust digital platforms and move to the next to the next level in digitization and yeah, like being able to digitize everything around us. Yeah, one day we will be like all virtual, I think. So yeah, so this is the conclusion of today's talk. We'll start with talking about the like the analogy between vending machine and smart contracts, and hopefully I give you a glimpse of how smart contracts are written and deployed and verified. I give you some of the challenges and highlight some of the challenges about smart contracts and some of the vulnerabilities in smart contracts. And there is solutions on the way. Just follow the money. And if you are interested in any of the projects that I mentioned or in smart contracts in general to do research in this field, please feel free to contact me. I'll be happy to put you in any of these projects or many other that we're working on. Thank you.
Thank you so much for
okay. I took more time than expected.
Well, yeah. Things sometimes do.
Yeah. Yeah.
But you know, thank you for that, and thank you for trying to make us understand what's going on here.
Yeah.
Now you mentioned you know, your own work is sort of towards making things easier. Mm-hmm. It seems to me that these things, and that applies not just to Ethereum smart contract, but also to the use of cryptocurrencies in general. Mm-hmm. It's not going to happen really. It's not going to really blow up until we make it so easy that it's basically a one-click solution.
Yeah.
So and if you're talking about you know, working completely online. We now go onto a website and we buy stuff, and you know, we get a chapter in a book, or we get a book, or we get hardware sent to our houses. But for the electronic stuff, we enter a Visa card code and hit enter, and you know, something opens up in our browser. This is reasonably easy, but it's not nearly as easy as it would be if you had a one-click operation in your wallet, for example.
Mm-hmm. Yeah.
So yeah, you know, where do you see this going? This ease of use. Yeah. And do you yeah. agree with me that that's really what's crucial?
Yeah. So there is, I mean, I see this analogy with the transactions that done through the Visa and other or any other acquirer or issuer for these kind of digital cards and electronic cards that we use today. The problem that I think smart contracts in terms of transactions that can help that currently these kind of electronic cards, they don't, and they can't provide solution for. One of them is when you have different kind of currencies involved, so the exchange, and when you have money transferred through boundaries like countries, when we have exchange between commodities and digital currencies. So for example, you want to buy gold and you want to make sure that when you buy the gold, you really buy gold, and I mean, you can do it today, but you need to trust the website that you're using or the entity that hold this gold. Can we provide these kind of guarantees? Well, without, I think, trust, it's very, very hard. So either we need to trust those third parties, giving them the power, or if we want to be free and we have this kind of trust between each other directly without the need for intermediary, then there is, I think, this need for such kind of solutions. It does not necessarily to be smart contracts though, but any approach that provide trust. I mean, there are many ways to maybe to achieve the same goal. One of them would be smart contracts, but you can think of like creating these hard-coded, such as vending machines code on like ROM, and burn them and sign them and say, okay, I will use those as my contracts instead of using a blockchain, and no one can change it. So, I mean, yeah, but anyway, we need trust. This is the point in order to achieve these goals. And in addition also to the digital currency, like digital currency is one aspect of that we need, in which trust. But how can I trust that I'm talking to the right person in the future? We see that like today we can fake everything. You can have like in the future, I think it's easy to forge even a complete video showing different kind of shape, different kind of, you can have the identity that you want. But we want to be able at the end to trace this back to some asset in life, actual one. And this is really hard too. So yeah, I'm not sure if I answered your question.
That's fine.
Yeah.
Fine. Yeah, no, that's good. Thank you. So we're open to questions. Any questions from anybody else? You're also free to put them in the chat box.
Yeah. For some reason, I can't see the chat box. Can you see it? Maybe I should stop sharing. Close this. Yeah, any questions?
Yeah, I was thinking about when you were talking about killing the contract.
Yeah.
Is the contract permanently on the blockchain? How is that implemented?
Yeah, so killing the contract is just it's an like it should be, of course, like it's governed by so the only one that can kill the contract is the owner of the contract, so the one that created the contract, and you just make it void, kind of. So it's like when you have a check and you like just say this is void, so it will not, like all functions will not be used after that, so it will not be accessible and all transactions will be failed, but it will not the main because you can't remove it because it's already like there was a transaction before with the same code, right? So in fact, this is a feature now where you can kill the contract, but the problem also with this, that you need to define the rules under which the contract can be killed. Because if I give the owner the opportunity to kill the contract, let's say that this is the contract that I started with, the one between me and Adam. If I can kill the contract at any point in time, then the contract become void again. So I defeated the main goal, which is providing guarantee for Adam that I will pay the money. So what you can do in these cases, you can put guards on when these kill actions can be happening and in what conditions these kill actions can happen. So maybe after, for example, 1 month, you can put kind of requirement that or a constraint that you can't kill the contract after 1 month. So all these are code, right? So it's you can do it, but the more flexibility you have, you're defeating the main goal of why smart contracts created. So this is debatable in general, like whether you use other contracts or other addresses referring to other addresses or making the contract itself void. It's debatable because it's also against the main goal of why we have smart contracts in the first place.
Okay, thank you.
Yeah, is it also did I give you the answer? If you can ask again, like if you did not give, like if you're not satisfied with the answer. So please make it a dialogue more than like question and answers.
One of the things that I worry about a little bit is the capacity of in your case, the Ethereum blockchain. You know, remembering from a year or two ago when the CryptoKitties completely swamped it.
Mm-hmm.
You know, how serious is this potential problem if people start to use this more than just for fun?
Yeah, so how serious is to use, for example, like the kitties, or the like how serious?
The CryptoKitties is just as good as you know, a use case as any other.
Yeah.
I have no problem with that per se. I have questions about the capacity of the chain. If it's enough to, you know, for people to have fun with CryptoKitties to drown the chain, to drown the entire network. Yeah.
So you're asking mainly about the scalability issue with blockchain in general.
In fancy words, that's what I'm asking, yes.
Yeah. So, I mean, scalability were a problem with the first, like from the Bitcoin chain to other, all of them inherit this kind of scalability problem. There was like recently several advancement in terms of some solutions to scalability, not in Ethereum though, like in new developments where they use kind of grouping, and so there is solutions for the scalability. These solutions though, again, does not provide the same kind of consensus that the original network provided. So this is I think the scalability issue is mainly a blockchain problem rather than a smart contract problem. There is a problem. I can't deny that there is no problem in terms of scalability, but there is no also seems to be other solutions. So all solutions that's available today, they're engineering solutions. So they try to provide better scalability using traditional approach that we know from distributed systems and networks for a long time, such as hierarchical structures, parallel grouping, in order to be able to solve the scalability issue. These solutions, the engineering solutions, will make us fall back to previous also cases. So this is happening all the time, like when, because I want to give analogy from the database perspective. So I once asked Stonebreaker, Mike Stonebreaker, who's like Turing Award winner and the developer of DB2, on this move toward this distributed database and Hadoop. And so his answers was like clearly that people create these kind of solutions, then they fall back to the previous solutions that's already available. So because like whether we're talking about consistency, availability, performance, okay, we can achieve all of them, and consistency is important. So making sure that the data is already correct is important. So this means that we will fall back to solutions that achieve those. I think there is clear analogy here with blockchain. So consistency, or being able to create this kind of trust through what we call immutability, were discussed for a long time in terms of like these consensus mechanisms that's available. And it is hard problem. It's not an easy problem to solve. And if we want to have really good like consensus, then we will sacrifice performance. There is no other solutions that sacrifice performance. So all engineering solutions will be in between. So, yeah.
Yeah, thank you. So,
yeah.
More questions, anybody? In that case, thank you very much for a very interesting presentation.
Thank you for having me, and I really enjoy talking to this group of people who are have enthusiasm towards a topic that also I love and like. So I'm always happy to be with you and to give this kind of talks, and also hear your feedback about the talk. I'm happy to be here today.
So you have more comments in the chat box for thank yous. This has been recorded and we will upload it. Christian will upload it to the YouTube channel of Rafmynta, the Cryptocurrency Foundation, and I will be uploading it for my students to their site at the University of Iceland.
Sure.
And I'm guessing you will find it on YouTube if you want to share it with your students as well.
Okay, great. Thank you so much for the opportunity. And yeah, we will keep in touch.
We'll be in touch. Yes. Thank you so much.
Thank you.
Bye.
Have a great day.